Jay's Custom Creations is sponsored by Bits and Bits. Use the code JBates to save 10% off your next router bit or CNC bit purchase at bitsbits.com. When I first started woodworking, there's three distinct stepping stones in the very beginning of my woodworking journey that really got me hooked on how awesome it is to make things out of wood. So the first stepping stone I would say is brad nails, butt joints, and glue. I made a tremendous amount of projects, utilitarian mostly, with brad nails, butt joints, and glue. Eventually, over time, I wanted to make things look a little bit better, so how can I hide the mechanical fasteners? Aha! Pocket hole screws. Pocket hole screws allowed me to make pieces of furniture that actually looked like furniture without seeing the mechanical fasteners, but also was a short amount of effort or time involved to keep my interest, to not get burnt out on how overly complicated this one particular process was. So after pocket hole screws, I wanted to make a joint that had no mechanical fasteners. One of the easiest joints to make that is really, really strong, and that is a half lap joint. If you're not familiar with a half lap joint, it's when you take two pieces of material, you lap them over one another, and where they intersect, you remove half the material thickness. And when you do that properly, you'll have the top faces of all your material on the same plane, and assuming that they're exact same thickness, you'll have the inside faces or the back faces all on the exact same plane as well. Now, that particular little characteristic isn't always the end-all be-all importance. You don't have to have them perfectly on the same plane. I like to exaggerate, visually add interest to the joint by making them just a little bit proud of one another, and you accomplish that by removing a little bit less than half the thickness from each one of these. So as far as how proud they sit, that's determined by the height of your tooling. That's easy to do. You can accomplish that in many different ways. Whether it's in this case, the table saw blade, a sliding miter saw with a depth stop, a router table, you can adjust the height of the bit, a handheld router with an edge guide, a circular saw with an edge guide. All of that is easy to do by raising and lowering the height of your tooling. Not going to cover that. The second thing that is where you'll get the most precision out of your joint is the width of the joint. Now, you want that width to be precise. If the width of the joint is too narrow, well, then your pieces won't fit together. If it's too wide, then you'll introduce racking like this, which is what you don't want. One of the benefits of a half lap joint is the mechanical connection that you get with interference along the sides of the joint, stopping movement in the other direction. That's one of the benefits that it shares with like a dovetail joint, which is seen as like the Michael Jordan of woodworking joints. Because when the glue fails, assuming you made the dovetail joint in the proper orientation against gravity, the physical joint itself will be held together because the shape of a dovetail is a wedge and it physically can't go through. The wider part of the wedge physically can't go through the more narrow part. There's that mechanical connection. Same with a half lap joint. If these are precise, this won't happen. I want to briefly run through this formula because that's not necessary at all, but it'll help you understand why what I'm going to show you on the table saw is so easy and precise and why it actually works. So your material width and your joint width are the exact same thing. You want to have a joint that is the exact same width as your material so they fit nice and snug. So these are interchangeable. The joint width is equal to the kerf, which is the groove or the waist area of your tooling, plus your distance traveled. We know what the material width is because we can measure the material, but we don't need to measure anything. We know what the kerf is because we can measure our tooling. We don't need to do that either, though. All we need to know is the distance traveled. Well, if you're trying to simplify one side of the equal side, just move everything to the other side. And if you have a kerf over here, you subtract a kerf. Subtract a kerf from both sides, and then you have material width minus the kerf will tell you what the distance traveled is. So you take your material and you set up the fence so that you remove only the kerf amount, and what you're left with is your distance traveled in stop block form. Let me show you on the table saw. Position your fence so that when you put your material up against the fence and gently push it down on top of the blade, the side face of your material and the side face of this tooth should be flush. Trust your fingers here. Your fingers can determine thousandths of an inch in difference. Very, very little minor differences here. You want these to be perfectly flush. Now, if this tooth is into the material too far, then your joint will be very, very tight. So tight that it won't fit together. If the tooth is too proud out away from the fence, you can feel it when you push your fingernail down here, it stops on that tooth every time. Your joint will be a little bit too loose. What you want is a nice, smooth transition. So I know this means that my material width minus subtracting this amount from the blade will give me the exact distance traveled in a stop block style measurement. It's worth mentioning for this particular setup, my blade height is not at half the thickness. Right now I'm just trying to establish the stop block before I dial in the half height thickness. So with it up against the fence, I will make my cut. And now this piece is the exact width that I need. Let's check the precision, making a lap joint with these two pieces. The first cut is made with the stop block up against the fence, and then I will remove it for the rest of the cuts traveling into the fence. All right, now if I can position myself in front of the camera here, we'll test to see how well these fit. First off, you can check the width by just going on any piece of material here, and there you go. That is the width of the joint is perfect, and that's from the Kerfmaker style stop block. But I did two of them, so let's put them together. And I think I dialed in the height as well. So there we go, a perfect half lap joint. The two pieces are nice and flush on the front side, as well as the back side. And the width is absolutely perfect due to this little piece right here, a Kerfmaker style stop block. It's just so much fun when things click together and you have that precision of the joint holding itself together without any glue or mechanical fasteners. Half lap joints are awesome. Always make one more piece of material the exact same dimensions as all of your pieces that will have the joinery, so you can use that extra piece to set up your tooling and even create a Kerfmaker style stop block like this. That's it for this video. You guys take care. Have a great day. And I'll talk to you in the next video.